Thanks, everyone. Glad to be here. I'm here today to talk about graphics, and PC graphics specifically in Battlefield 3. A lot of PC graphics fans here, I guess? Yeah! Awesome. I'm from DICE, which is a studio in Stockholm, Sweden. Yeah. Here's just a couple of shots of our studio. It's a pretty nice studio we have. That's me, up in the right corner, sitting working. I like to collect monitors when I'm not, spend time like that. I guess most of you guys have played these games before that we've been working on. How many here have played all of these games? Yeah, okay. Yeah, that's awesome also. So I'm going to talk about BF3. As all of you guys know, it's a 64-player multiplayer game, our big return to the actual true Battlefield experience. We also have single-player and co-op, but for the PC audience, that's usually not that interesting. But they're pretty fun also. One thing that's really new and cool about BF3 is that we have these giant, large landscape environments, as well as both urban and indoor environments that I hope you guys will like and see. And we've developed this game for quite many years now, and PC has always been our lead platform, the way we really wanted to design and develop the game for. And in order to do that also, we've added the requirement of having DX10 and DX11 because we're able to write more directly to the GPU, and it's a lot more efficient for us to work in that sense, to really take advantage of all the new features in the GPUs. And in order to create BF3, we created a new engine, or a new major revision of the engine, of the Frostbite engine that we've been working on for quite some time, called Frostbite 2. Where we've done some massive enhancements and improvements with regard to both animation, rendering, lighting, destruction, as well as our landscapes and general streaming systems. So it's been a pretty major revision that we've been working on for a long time here, with PC as a focus from the start. But I'm here today to talk about graphics. So let's just jump straight into it. Here we have a pretty fancy screenshot from BF3. This specific part is the single player, so this is one reason to play single player. The graphics there in certain type of environments are really awesome. It looks cool in multiplayer also, but it's a little bit different experience in single player, the way you play the game. One important thing when you're talking about graphics, though, is that most people look at the screenshot and say that has good graphics, which I hope you guys agree with this screenshot also. Yeah, but it's important to really consider that graphics is really the core portion of how the techniques of how you show things on the screen. It's not really what makes a screenshot pretty or what makes a screenshot visually pleasing. Graphics is the core component there. What we're seeing here really is the sort of aesthetic of the picture, that we're trying to build a full picture where everything fits together. So it's not just about the shiny shader or a good lighting effect or a good terrain rendering method. It's when all of these things come together, they form sort of a whole and create a pleasing aesthetic of the game. And there was actually a really cool talk, well, not a talk, a really cool presentation they had a few weeks ago on Penny Arcade about the difference between graphics and aesthetics. Aesthetics is the A here, and graphics is really a way needs to be a method of serving aesthetics, and also gameplay in our sense of word. And I think many games are sort of missing this key correlation between aesthetics and graphics, that graphics is really there to improve the aesthetics and the visual style you have for a game to create a pleasing whole of it. It's not the end goal in itself. And also with gameplay, we've seen that more and more now. That as we add more graphics, we add it in a way where it actually improves gameplay. You see more, you get better visibility on your levels, you see muzzle flashes in dark areas, you actually see those snipers hiding out or things like that. So this is just a core thing I wanted to clear up starting out. But let's jump into the graphics and some of the visual major components that we have in our engine, in our game. So I sort of divided up this into 5 major areas that I'm going to talk a little bit about, and then finish off with some more stuff. The first thing is how we handle objects in general in our scene. Objects is a huge portion of everything that you see. Then we also have the lighting engine that we've done massive improvements to create different types of environments. And then the way we do effects, which has always been a big thing for Battlefield. Landscapes and terrain is also another big portion there, and also post-processing that we're working on. So we'll go through these individual components and talk about a lot of details in between those. So let's start out with objects. There's really quite a lot of different types of objects we have in our engines and in our game. Every single soldier you see, every single vehicle, every tank, every helicopter, those are very important gameplay objects. Those are really what the game is. You are a soldier. You're controlling a soldier that's shooting on another soldier or a vehicle or a tank or something like that. So those are key gameplay objects that are really, really important for the rendering and for the game in general. We also have tons of environment objects like trees and bushes in order to create a suitable landscape, as well as man-made objects on certain levels, like, buildings, fences, containers. And then effects is another portion also. So, but in order to be able to handle huge amounts of objects on a level, we can have up to 10,000 different types of objects on a level. It really requires a lot of effort in the engine and in the gameplay as well, in order to render that efficiently and handle that and make it fit into memory. Even on a very high-end GPU, you still have a limited amount of memory. So we have some really interesting systems on how to manage and stream meshes and textures. We do LOD and distance culling in a lot more expanded way than we've done before. We also have an occlusion culling system, which makes rendering fast by not rendering things that you don't see, which kind of like make a lot of sense. One thing that's always been strong with Frostbite and we've improved further on is to be able to do parallel rendering, to utilize all the multi-core PCs out there, a quad-core or even more CPU cores, to render the entire world that we have in parallel and also simulate all the vehicle physics as well as the trees swaying in the wind and all of those type of things. So I'm going to talk a little bit more details about a couple of these very important points for the way our engine is improved. With regard to mesh and texture streaming, that's something we haven't really had before in Frostbite or in really any Battlefield game. Previously, you just filled up memory in the engine and then, let that run and had some graphics options in order to scale it a little bit. But back when we did BF2, we saw that there's some issues with doing that approach, that there's so many different PC configurations, so it's kind of difficult to just fill up memory and then hope that that works, because there's so many different configurations of memory and of what type of settings that you have. So streaming assets has a lot more flexibility there, because we can overall just reduce the memory amount that we require to be persistent at when running. We have a smaller set loaded, so we run on more different configurations. But we can also do it the opposite way. We can increase quality by using that memory in a better way and add a lot more variety in the levels by having tons of unique meshes and unique textures everywhere. And this really creates a freedom for our level artists and level designers when they create the levels. They don't really have to think that much about, does this fit in memory? They just have to add a lot of content on the levels, and then we stream that automatically. And this is something we do both in single player and in multiplayer, and on all platforms. The way we do this, the core streaming is it's based on not the exact frustum that you're having, the exact viewing direction, because that simply doesn't really work that well on PC. When you're running with a keyboard mouse and you're rotating quickly with the mouse, you can't really stream stuff fast enough for that to work. So we just base it on the camera position, where you are on the level, and the distance to individual objects and textures, and prioritize that and load it in the background. And there's a lot of games that's been doing this for quite some time and done it reasonably successfully in many games also. But one problem that we've had for a long time in the games industry in general, I think, is that most of these games that have used streaming has been doing it in DX9, and you can't really do it in DirectX 9 very correctly, because there will be CPU spikes when streaming in new content, because the APIs are not really designed for that approach. So we've been working pretty closely with both Microsoft and all the IHVs, such as NVIDIA, to come up with a solution in DX11 where that's actually built into DX11, where you can have a separate thread that creates all your textures and create all your meshes, and the drivers are specifically optimized for this case that make sure these giant textures that we're loading are uploaded in parallel, so you don't see any CPU stalls based on that. And that's really important in order to utilize the technology quite a lot. So a couple of examples of what we stream. On a multiplayer level, we typically have around 200 and 250 megabytes of meshes. That might not sound that much, but if you consider that most people have a graphics card of only a gigabyte, then taking up a quarter of the memory just for meshes, which is just a pretty small portion of the rest of the things that you have, then it actually becomes quite interesting to stream a portion of that memory. And then with regard to textures, we have a lot more. We have up to 1.5 gigabytes of textures on any single multiplayer level. And while there are cards that have 1.5 gigs of memory, that's not really the norm. People with a lower-end card, or even people with a higher-end card and running at high resolutions, they can't really fit all of that. So that's a major reason why we stream stuff. So these settings are primarily set through the texture quality and the mesh quality settings in the options, where we set a different type of pool size, how much textures and meshes they have loaded in memory at a single point. So for high, we use 300 megs, and for ultra, we use 500 megs. So ultra is mostly designed for 1.5 gigabyte graphics cards primarily, or better. This has been working out really quite nicely for us, and I haven't really heard anyone having problems with it either, so that's a good sign. Another aspect with regard to talking to objects is these quite complex levels. This is one of the levels you can play here, Damavan Peak. And if you look at it, these are a lot of objects being rendered here at a high distance. You're sort of flying here. But if you look at it, a lot of these objects are really the same type of object, because these are like oil cisterns or something that are just, we're just rendering them multiple times. The artist just placed the same object there. And there's tons of other smaller objects that are the same. They're just repeated. And typically, rendering these type of things can be really quite heavy because there's so many objects. But this is another really good DX11 optimization we've done specifically for Frostbite 2, and spent quite a lot of effort of trying to do this, is that we use a method called instancing. So we take all of these, I'm not sure how many it is, 10 objects, and render them with a single draw call. So we send a single command to the GPU to render all of these at the same time, which massively reduces the CPU burden to render this. And we can do this type of instancing on all of the different types of meshes that we have on skin trees, or on these type of meshes, or even on destructible buildings that actually look really quite different. This massively reduces the amount of draw calls we have. So this level, in this exact view, had 4,000 draw calls when running an ultra config, because in ultra we further reduced the LED distances and the culling distances, so we see even more for further distance. So this dropped it to less than a quarter of the number of draw calls there, so which massively reduces the CPU cost of our rendering. And makes it faster both on the low-end cards, because there you perhaps only have a dual core or something like that rendering takes quite a lot of CPU on. But also if you have a really good machine, well, then you run on the higher configs, and then also benefit from reducing the number of draw calls we have.